Alright, so we're going to take a look at the many ways of evaluating limit. We're going to need to create 7 tabs. So take a sheet of paper or take a ruler and tear it all the way down the margin. So on the first one, tear it all the way down on the margin. On the second one, start the very first line and tear it all the way down on the margin. On the third one, count 4 lines, tear it to the margin, and then all the way down, just like I'm doing in this video. Alright, on the next one, leave 4 lines again, and then tear it to the margin and down. Alright, so you're going to do this and you're going to end up with 7 tabs. So 4 lines should do it, and then I think one of them is going to have 3. So just go ahead and follow that so you see how it's just turning out to be tabs. So you take each page, 4 lines, to the margin and down, to the margin and down. Alright, so once you made your 7 tabs, you're going to go ahead and put in all the papers. They're numbered, so the first one goes on the second page, the second one on the next page, the third one on the page after that, and so forth. But you're going to leave the very first page blank for the title. So just keep putting in all of them in. So all these pages, all these tabs will be filled, except that last one, which we'll just do some practice problems on there. So again, you're leaving the first one blank for the title. So your first tab is going to have your first page, your second tab, your second page, and so forth.
Here I am, Lord. Here's my life, Lord.
Alright, so I've gone ahead and written the title, Evaluating Limits. Now I'm just going to put in all the tabs. So the tabs are obviously titled or whatever the title of the sheet of paper is. So I'm on the second one, so it says factor. So number 2 is factor, second one is factor. The next one is conjugate, so the next one is conjugate. So you're just titling the tab, the paper that's already there. Okay, so that in case you don't put it in the same order that I did, that you're still naming your tabs correctly. So just whatever sheet of paper is on that tab is the name of that tab. You're going to do this all the way down. Alright, the last tab is not going to have a paper, so that last tab you're just going to type in or write in, practice all limits, because we're just going to practice all of them together. So practice all limits is the last one. So this is what it looks like. Put some color on it, of course. So evaluating limits, then factoring, then conjugate, then compound fractions, I think that's what that says. It might not be big enough for me to see, etc., etc., all the way down. If your tab is in a different order, don't worry about it. It's okay as long as you have all 7. Alright, so we're going to take a look at the first one, evaluating limits. This one is by far the easiest and the one you should always try. Alright, evaluating means to find the value of. Okay, so all you're going to do is just put in the value of the limit in and seeing if it works. Alright, you follow those 3 easy steps and see what happens. So if I plug it in, if I plug in 1 every time I see x, I'm going to get 1 minus 1 over 1 minus 1, which simplifies to 0 over 0. Well, does that work? No, because that's intermediate. When you have 0 over 0, it does not work. How about the second one? When you plug in 10, what are you going to get? So it's going to be 10, where you see x, 10 over 2 equals 5, which works. Same thing here. You plug in 0, it's going to be 0 plus 2 over cosine of 0. Well, that's 2 over cosine of 0 is 1. And so 2 over 1 is equals 2, so that works. Next one, 0. 0 plus 2, actually this is exactly the same one. So 0 plus 2 over cosine of 0 equals 2 over 1, which is 2, which means it works. So if you get a value, plugging it in works. It didn't work with the first one, but for the rest it did. So it gives you a quick and easy answer. Remember, intermediate is when you have 0 over 0. We don't really know the value of 0 over 0, so it's called intermediate. Limits of continuous functions can be evaluated with direct substitution. So everywhere you see x, you're going to put -5. So don't write the limit, don't write what I just wrote, just put in the values. So when you put -5, this is what you're going to get. Everywhere I put x, I'm just putting -5. When you evaluate that, you're going to get 3 times 25, because -5 squared is 25, minus 20, minus 5. Okay, we evaluate that, 3 times 25 is 75, minus 20, minus 5. Then go ahead and combine all of those. 75 minus 20 is 55, minus 5 is 50. And that's it. So don't put limit, actually, just because I'm going to put equals. So the limit of the whole thing as it approaches -5 is 50. Alright, next one. Plug in -2. So everywhere I see p, I'm going to put in -2. So it's 2 times -2 plus 4 over 3 times -2. And then evaluate it. 2 times negative 2, negative 4, plus 4, 3 times negative 2, negative 6. 0 divided by negative 6 is 0. You just can't do anything divided by 0, but you can divide 0 by a number. Alright, next one, last one. Everywhere I see an x, plug in a 0. E to the 0 is 1, so just replace that with 1. Sine to the 0 is 1. And then you have log of 1. 3 times 1 is 3, minus 1, log of 1 is 0. So 3 minus 1 is 2. And that's it. Okay, so this is by far the easiest one. So let's take a look at what if it doesn't work out where you can just plug in it. Well, the other thing is you can factor. Okay, so you can factor. So we're going to factor the top. So that's going to factor to x minus 1, x plus 1. So on the top we have x minus 1, x plus 1. On the bottom we have x minus 1. When you factor, notice that you can cancel like terms. So you're going to cancel x minus 1. And now you're going to left with x plus 1. Now try plugging it in. So wherever I see x, I'm going to put in 1. So the limit as x approaches 1 of this function simplifies to x plus 1. So where I see x, I put 1. So 1 plus 1, which is equal to 2. So you see now we're able to find the limit even if you plugged it in. So x squared, so 1 squared minus 1 is 0, and then 1 minus 1 is also 0. So you had gotten an intermediate thing which you couldn't just do by substitution. So you can factor it so you still could find the limit. Let's do another one. So as h approaches to 0. Right, so again you could factor. So with this one you first need to expand it before you can factor. So I'm not sure what method you use, but I'll do the box method to expand it just so I can make sure that I don't make a mistake with expanding and combining like terms. All it is, you're just multiplying the same thing 3 times. So I multiply each thing. Then the diagonals are already lined up for me, so I add them up. So I'm going to get h squared plus 6h plus 9. And then I'm going to multiply that, so I'm going to make another box. Multiply that again by 3 plus h, and I'm going to put it in order, so h plus 3. Well, I guess I don't. Or maybe I do erase it and put it in order. Look at me go. Alright, so h plus 3. So you just multiply box by box. So h times h squared, h cubed, h times 6h, 6h squared, h times 9, 9h, so forth. And then when you do it this way, it makes sure that you don't leave any terms. So that's going to be h cubed, and then line up the diagonals. So the limit of h cubed, and then that's going to be 9h squared. That's going to be 27h and plus 27. Alright, then remember that's just expanding that, so minus 27 all over h. So that 27 is going to cancel with the other 27, because 27 minus 27 is 0. So all I'm going to have is what I'm writing down now, all over h. Then what can I do? I can factor out h. Alright, so I can take out h. When I factor out h, what do I have left? The listening check. This is a listening check. Underline the word cancel under number 2 in the notes. Underline the word cancel in number 2 in the notes. So that h cancels with that. So what do I have left now? The limit as h approaches 0 of h squared plus 9h plus 27. So plug in 0 everywhere you see an h. So 0 plus 0 plus 27. So 27. So even though, again, let me prove it to you, if you plugged it in the beginning, you'd have gotten an intermediate value, 0 over 0. So where you see h, plug it in. Plug in 3 plus 0 cubed minus 27 over 0. So 3 cubed is 27. 27 minus 27 is 0 over 0. So again, we'd have got an intermediate. So sometimes factoring would help you. So let's practice some. You should pause the video and see if you can do this without me first. In the top, taking 2 out, we'll leave what I have written down. Then factor in the bottom, x minus 5, x plus 2. Then you see that x plus 2, they cancel. Because at step 2, cancel like terms. Then you have 2 over x minus 5. Then go ahead and plug in what x is approaching. So as x approaches negative 2. So everywhere you see an x, put in a negative 2. Simplified. So it's going to be 2 over negative 7. And obviously we always put the negative on top or on the side. So negative 2 over 7. So the limit as x approaches, negative 2 is going to be that. I want to do the same thing on this one. So hint is the sum of cubes. If you know the shortcut, you can go ahead and do it. But I'm going to go do it the long way in case you don't know it. So I need to find one of the factors. Since I know 3 cubed is 27, I'm going to start with 3. So I'll try negative 3, and all you're going to do is plug it in. If I get 0, it's one of the factors. So once I plug this in, I get negative 27 plus 27, which is 0, which means x plus 3 is a factor. Once I have that that's a factor, I just know that if I multiply it by something, I will get the x cubed plus 27. So what I'm going to do is I'm going to divide x cubed plus 27 divided by x plus 3. If you need a refresher, go to dividing polynomials. It's another video and you can kind of watch it through. This is a listening check. This is a listening check. Color in x plus 3 is a factor. X plus 3 is a factor. Go ahead and put some color on x plus 3 is a factor. So I get x squared minus 3x plus 9 is the other factor. So what we're saying is x plus 3 times x squared minus 3x plus 9 is going to give you x cubed plus 27. Okay, so that is how you factor that all over x plus 3. Okay, so you cancel like terms, you've canceled them. And then just plug in. So now everywhere I see an x, I'm going to put in negative 3. Negative 3 squared is 9. Negative 3 times negative 3 is positive 9, and then plus the 9 there, so that's going to be 27. So the limit as x approaches negative 3 for this function is 27. Alright, so again, factor the top. Okay, so I use the box method for this. If you need a refresher on this, there is a video. It's called factoring. Alright, so two numbers that go to 10 is 5 and negative 2. So I draw my 2 by 2 box. Put the first term in the first box, the last term in the last box, and the two factors you found in the remaining boxes. The order does not matter. Once you've done that, you're going to take the greatest common factor horizontally, so in this case it's going to be t. T times blank is 2t squared. Blank times 2t is negative 2t. T times blank is 5t. Negative 1 times 5, the last box, negative 5. Factors on the side of the box, so that's t minus 1 and 2t plus 5, all over 1 minus t. Now, we need to make this look like 1 minus t, so that we can cancel it. To make it look like that, you just can rewrite it. Take out a negative, and so that's going to leave negative t plus 1, or rather 1 minus t. Now it looks exactly the same, so now we can cancel it, and we have negative 2t plus 5. So we're finding the limit as t approaches 1, so everywhere I see t, I put 1. 2 times 1 is 2, plus 5. Work out the parentheses, that's going to be negative 7. So example, negative 1 plus h squared. That's going to give me 1, then negative h, and then another negative h, that's negative 2h, plus h squared. Alright, so when you factor that out, it's going to be 1 minus 2h plus h squared minus 1 all over h. The 1 minus 1 is going to cancel, so leaving negative 2h plus h squared over h. I'm going to factor the top, take out h on the top, leaving negative 2 plus h. Again, cancel like terms, top and bottom, leaving negative 2 plus h. So the limit as h goes to 0 of negative 2 plus h. This is a listening check. This is a listening check. Go ahead and box negative 7. The answer to question 3 alone. Box negative 7. Is equal to negative 2 plus 0, which is equal to negative 2. That's it. Let's go ahead and practice.